Hello everyone. Today I am going to discuss about the case study on technological quality of irradiated Moroccan citrus fruits. First, introduction. Citrus fruits it occupy a very important place in the Moroccan agriculture with a yearly production of about 1.5 million tons. The production in citrus fruits was 1.237 million tons. More than one third of its production are destined for export and constitutes a foreign exchange resource, and therefore it is important for the Moroccan economy. The most exported varieties are the Nevelia, tangerines, clementines, and Moroccolate. However, the Moroccan citrus fruits suffer, as all countries of the Mediterranean area, from the attack by the Mediterranean fruit fly, Ceratus capitata, that causes considerable losses. In view of this, there is a necessary for a quarantine treatment to be able to export them. In Morocco, this treatment is done by refrigeration at temperatures between 0 and 2 degrees Celsius for a period of 16 days, coupled with a fungicidal treatment during the temperature conditioning. However, this method has many limitations, of which most important are the elevated cost of the operation, the difficulty to reach the faraway markets. The technique of irradiation, it seems to be preferable treatment method in order to reduce the post-harvest losses and to increase the quality available for marketing and export. The combination of irradiation and storage at moderately cold temperatures has another advantage that would permit to replace the cold treatment at 0 to 2 degrees Celsius, thus reducing the cost of the treatment. Moroccan citrus fruits require a quarantine treatment by irradiation at a dose of 225 gray minimum. In this work, the effect of irradiation was determined on the Moroccan orange quality at doses commonly used for quarantine treatment. Thus, in the first study, we are going to see about how the export variety Moroccolate was irradiated without previous cold treatment, and in second study with cold treatment. The applied doses of irradiation are 125, 250, 375 and 500 gray and a control sample. Temperature of storage were at ambient temperature under 10 degrees Celsius for irradiated and 0 degree for control. Materials and methods. In the first study, the variety Moroccolate harvested from the experimental orchards were used. The fruits has not undergone any previous treatment for conservation. Oranges received in bulk lots were sorted out to eliminate the damaged fruits and divided into 10 kg lots for different treatments. In the second study, oranges of the same variety previously conditioned were used. Fruit samples were packed in parallel wooden boxes of 11 and 5 kg weight and covered by nets. These boxes served as the containers for irradiation. Then, irradiation treatment. In both studies, fruits were irradiated to the dose of 120 to 500 gray along with the unirradiated control. For the present study, doses up to 500 gray were employed. Following the irradiation, fruits were stored at ambient temperature and 10 degrees Celsius and the control samples at 0 degrees Celsius. In the first study, we are going to see the sample carrier was a container formed respectively of two coaxial cylinders of diameter 40 and 16 cm with 25 cm height. The products were placed between the two cylinders and the device was connected in order to receive a good uniformity of doses. The dosimeters were the red perspex. In the second study, oranges were irradiated in the packaged boxes. Two rotating tables have been used and the dosimeters used were gamma chrome files. Following the dose distribution studies, fruit samples were irradiated to different doses in accordance with the dosimetric studies and various qualities were tested. Next, results and discussion. First, we are going to see about yield of the juice. There was no considerable variation in the juice yield between unirradiated fruits and those irradiated of doses from 125 to 500 gray. The juice's yield nearly remained the same in fruits stored at 10 degree and 0 degree Celsius during 4 weeks of storage. It confirmed that the values of the density of juice and ensured that in fruits irradiated to different doses and stored at any temperature for 1 month, the value did not differ from the unirradiated control samples. Next, about change in the total volatile acidity. The total volatile acidity contents between control and fruits irradiated to different doses during storage for 1 month at any of the temperatures under study. Next, dry matter and bitrix. The soluble solids content in the orange juice and dry matter of the peel were not affected by irradiation up to 500 gray or the temperature during the storage up to 1 month. The variation observed in the dry matter content of peel was probably due to natural evaporation and not due to irradiation. Next, about reducing and total sugars. The results showed that neither of the reducing sugar or the total sugar were changed by dose of irradiation under any of the temperatures during storage for a period of 1 month. These results were similar to that observed of the dry matter content of the variously irradiated fruits during storage under different temperature conditions. Next, about loss in weight. In oranges, the loss in weight functions as the storage period that shows the loss in weight increased with increase in irradiation dose. It was valid for a period of 3 weeks of storage for the two storage temperatures, namely ambient and 10 degrees Celsius. What they are saying is that the loss in weight increased with increase in irradiation dose. This variation remained weak and never exceeded 10% of the loss in weight. This variation of the weight could be explained by increased evaporation due to alterations in cell wall constituents of the peel as a consequence of irradiation. Next, conclusion. The study shows that irradiated at dose levels required for quarantine treatment, it did not affect the technological quality of citrus fruits adversely during 4 weeks of storage under the test conditions. It can be used with success instead of the classical methods of conditioning to limit the browning of the peel. A future study will examine the use of waxing to control the browning phenomenon. Thank you.